Hello, and welcome to the beginning of this new series, intended to teach how to build an operating system from scratch. In this episode, we will look at a lot of theory about operating systems that is absolutely necessary for creating one. So let's see what we're up against, and prepare for battle. Making an operating system is as hard as programming can get. It shouldn't be your first big project. You must know the programming language that you have chosen very well. For example, if you are using C or C++ and you don't understand pointers or data structures, you cannot create an operating system. Another problem that must be solved is the programming language chosen. As a general rule, only low and medium level languages can be used. C, C++, Pascal are good languages. C#, PHP, Java are bad languages. Don't think that copying and pasting from tutorials will make you an operating system developer. You must understand what your code does, otherwise you can get stuck at a point where your creation doesn't work, and you won't be able to fix it. Many of you watching right now may have great ideas or dreams of how your future operating system will look like, what kind of features it will have. Well, I'm here to destroy most of these dreams. For example, quote, "My operating system will support applications made for Windows, Linux and Mac." Yeah, sure, like that was as easy as saying hello. There is a project under development called Wine, and the aim is to make Windows applications run on Linux. Well, this project has been going on for 15 years, and it still needs many more, since Windows is much more complicated than it looks like. Another mistake beginners make would be deadlines. An operating system takes years to make. Look at Windows 7 for example. To get here, Microsoft started with Windows NT 3.5 in 1993, which was almost 20 years ago. Of course, Microsoft had a large amount of human and material resources to spend on this project. If you want to create windows, menus, pictures, buttons and so on, this is not the right place for you. Although a modern operating system includes a graphical user interface, this is not the main purpose of the operating system. There is no point in trying to create a whole operating system if you only want to create the user interface. If that is what you want, then try to create a Windows X Manager for Linux. The user interface itself is an application that runs on top of an existing operating system. On Windows you may not understand the difference, but let's look at Linux. There is the Linux kernel which runs behind what you see, and there is the graphical user interface, which is an application, for example GNOME or KDE. Another mistake would be assuming that an operating system will make you rich. This is not true, since there are operating systems out there that are superior to popular commercial operating systems like Windows or Mac, but good marketing strategies made Microsoft and Apple rich. Usually, beginners think that multiple persons working on the same project will increase efficiency and make things work better. But most times this is not true, just like the saying says, too many cooks spoil the broth. Now in the second half of this episode we will make a checklist of everything we need to create the operating system, and in the next episodes we will set up everything we need. This checklist can vary depending on your preferences and possibilities. First of all, we need two computers. One of them will be the one on which we write the code and compile, and the second one will be our test bed. The test bed can also be a virtual computer, which we will use in this series, but if you have the possibility, you should use a real computer from time to time to make tests and make sure everything is working perfectly. This is because real hardware doesn't behave the same way simulated hardware does. We might have code that works on a virtual computer, but doesn't on a real one. For the first computer, there are several tools that we need. First of all, the compiler. We will need a cross-compiler, which can build programs for any operating system, and even build the operating system. On Linux, we will use GCC. On Windows we will use DJGPP. On Windows, we can also use Microsoft Visual Studio. Secondly, we need an editor to write our code. We can use a simple text editor, like Notepad2 or gedit, editors that have syntax highlighting that helps us understand the code better, or an IDE, also known as Integrated Development Environment. An IDE can offer us features such as IntelliSense in Visual Studio, and many other IDEs have this. On both Linux and Windows, we can use Eclipse or NetBeans. On Windows, we also have Visual Studio. Thirdly, we need an assembler. An assembler is a compiler for code written in assembly. We will talk later about what we need it for. We will use both on Windows and on Linux NASM, or NetWide Assembler. As an alternative, you can use GAS, but it has a different syntax which is harder to understand. As a note, inline assembly code for GCC and DJGPP uses the GAS syntax, and not the NASM, but fortunately there isn't too much inline assembly we will write. Next is the old floppy drive. Don't worry if you don't have one, we can use some tools to create a virtual floppy disk. On Linux is a trick with DD and mount, on Windows we will use virtual floppy drive. The only problem is that we cannot test on real hardware with virtual floppies. We will also need a debugger. We will use both on Windows and Linux a debugger called Box. And lastly, we need an emulator for the virtual computer. On Linux, we can use QEMU. On Windows there are many possibilities, for example Microsoft Virtual PC, Sun VirtualBox, or VMware. Some other useful tools will be a hex viewer, and debug, which is a Windows application. We will talk about these when we will actually need them. This is where we end this very first episode. In the next few episodes we will install and configure these tools, both on Linux and Windows. I hope you now understand what we are up against, and I hope you will not make some of the same mistakes I did back when I started learning about this kind of programming. If you have any question, feel free to ask on the blog. You can also write me an email. My address is kabichi@gmail.com.